Alright guys, this is part 2 of the Module 5 test study guide, and we got interrupted. Students were coming back. It was getting a little crazy in here. So here we go. We were looking at number 7, which says Deepa wants to compare 9/3 and 9/6. So the big challenge for students has been understanding how we go from smaller fractional units, meaning smaller pieces like a sixth, to a larger related unit like a third. So when we left off, I was showing how if I had a number line that was in the exact same place and I partitioned that number line into thirds, or 3 pieces between each number, I could then turn those thirds into 6 pieces by breaking each third into 2 pieces, or breaking it into halves. So when I'm looking from the opposite end and I have 6 pieces, but I need to find thirds, I basically do the opposite. I put 2 pieces back together, or I skip every other one. So if I'm starting at 0 and I put together 2 pieces, this represents 1/3 on that number line. 2 pieces, that's a second third on that number line. 2 pieces, that's a third on that number line. So if I continued that pattern and I made those thirds more obvious, every other one basically is going to make a third, because thirds and sixths are related by doubling or halving. Then I can now label both my sixths and my thirds. Okay? If I want to label my thirds, I would start at 0. At 0, I have 0 of 3. Then I have 1 of 3, 2 of 3, 3 of 3. When I have all 3 pieces, I have one whole thing. 4 of 3, 5 of 3, 6 of 3, 7 of 3, 8 of 3, and finally 9/3, or 9 of 3 pieces. 9/3 is the same as 3 whole things. Okay, I also need to label 9/6. So remember, the original number line was labeled with 6 partitions between each whole. So 1, 2, 3, 4, 5, 6. So I'm going to count those to find 9/6. If I'm at 0, I have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And I remind students to double check themselves when they get to whole numbers. Does that make sense? If I have 6 of 6 pieces, I have one entire whole thing. 7/6, 8/6, 9/6. So we're going to put that one on the number line as well. And now I can compare. When I find 9/3, I can see, because it is further down the number line, that it is bigger or greater. So I use this symbol to show greater than. 9/3 is greater than 9/6. Another thing that we have talked a lot about is the bigger the fractional unit, or the denominator, the bigger the fractional unit, the smaller those pieces become, because I've chopped it into more and more slices, or more and more pieces, and these pieces get smaller and smaller. So when I'm comparing and I have the same amount of parts, but different denominators or different fractional units, the larger that fractional unit, the smaller it actually is. Just to illustrate that, if I had 1/3 and I was comparing it to 1/6, here I would have 3 pieces. Here, this one is in 3 pieces, but I have to make those in half to make 6 pieces. Clearly, this is a bigger slice than this. The more slices you make, the smaller the fractional unit becomes. All right, number 8. Mr. Davis shows his class a point on the number line. So here is the point on the number line. He asks, what fraction is represented by this point? We have 2 different students. Liz writes 4/4. Luke writes 2/2. Show Liz's answer on the top number line. That's Liz's number line. Show Luke's answer on the bottom number line. And for each, it says partition each whole number interval and label the answer. So I have to go back and see what was Liz's answer. Liz labeled this 4 of 4 pieces, or 4/4. That means that Liz is partitioning with fourths, or 4 pieces between each whole number. So I'm going to have 4 pieces here and 4 pieces here. Each interval gets its own 4 pieces. So we're going to half it and half the halves to create 1, 2, 3, 4 pieces. We're going to come over here, half it, half the halves to create 1, 2, 3, 4 more pieces. That's what Liz did. Go back up, refer to what Luke said. Luke wrote 2/2. Luke's fractional unit is halves. That means he only cut each whole number into 2 pieces, or halves. So my half should be in the same location as the top number line. When I look at those, each one is in the exact same place. So when I come down to part B and it says explain why Liz and Luke are both correct, they're both correct because 4/4 and 2/2 both represent 1 whole. They are equivalent fractions. And that's been a big vocabulary word for us. Equivalent fractions, meaning those fractions live in the exact same place because they represent the exact same amount. All right, looking at our last question on this study guide, it says, use the number line to complete the equations. So this is the concept that when you have an item, such as a brownie, we've used brownies a lot, and I have 1 brownie, and I do not cut that brownie apart at all. I leave it as 1 whole brownie. I represent that as 1 of 1 whole. I have 1 of a whole. This next number would say that I have 2 brownies that have been left in 1 whole piece. So I have 1 brownie that's a whole, 2 brownies that have been left as 1 whole piece. The bottom number tells me how I partition, or the fractional unit, and the fractional unit is a whole, or 1. This would continue here. I would have 3 whole brownies, and I have not partitioned any of those brownies into pieces. They have remained 1 whole. So I have 3 wholes, 4 wholes, 5 wholes. Okay? So when I'm looking at that, they have laid those out to show they are equivalent to a whole number on the number line. So I simply find the number 3, and if I have the number 3, I write that as 3 over 1, or 3 wholes. If I have 2 wholes, or 2 over 1, I write that as being equivalent to the number 2. And if I have the number 4, and I'm wanting to show equivalency, I would say I have 4 wholes, or 4 of 1 whole piece. All right, I hope that was helpful for you, and may your studying go well. Thanks a lot.